Welcome to Achieve Tech Academy, and today we'll be starting Unit 3, that is three-phase circuits. Today we'll learn how to analyze a three-phase balance circuit, and this video will be in two parts. This is part 1, and in the next series will be part 2. So kindly remember to like, share, and subscribe for more contents like this. So without wasting much time, let us dive in. So we want to look at how to analyze three-phase balance circuits. So these are some tricks that has really helped me over the years that I want to also share it with you. So first of all, a three-phase balance circuit has three identical loads in all phases. So it has three phases, either arranged in delta or star. So it has three phases. So the current that flows in a three-phase balance a three-phase are equal in magnitude, and they are also 120 degrees apart. So we have the plus 120 and the minus 120. And in a balanced three-phase circuit, it is analyzed by just when we are analyzing, we just consider just one phase. So after considering just one phase, we can calculate the total power by simply multiplying the current or the power in one phase by 3. So that is how we simply do it. And this is one trick that you have to take good care of. So let's say when you are calculating a question, and let's say you have a parallel and a delta, the series they are parallel, and you realize that one is a delta, the circuit is parallel, the one is a delta and one is a star. You have to change the delta to star. That is it. You always change the delta to star. It's very important. We always change the delta to star. So we have to change the delta to star. So to change the delta to star, you might ask yourself, how do we change the delta to star? We simply change the delta to star by dividing the delta value by 3. So let's say if let's say the delta was Z1 here is equals to 2 plus maybe 10J. So we can change it to star by just dividing Z by 3, which now becomes 2 plus J10 all over 3. So we've now changed it to star. That is how we change it to star. And whenever you are also given a question and the question doesn't state whether it is a star or a delta connection, always assume that it's a star connection. That is how we take it. So if it doesn't state whether it's a star or a delta, we just assume that it's a star connection. So without wasting much time, let us go into the formulas that we use to calculate the delta and star. So let's look at our formula sheet. So with our formula sheet, we have two arrangements in a three-phase circuit. We have delta arrangement and star arrangement. So for star arrangement, we realize that what we have to know is that for star arrangement, VL, which is the line voltage, is equal to root 3 of the phase voltage. These are formulas that you have to keep at the back of your head. You have to really know these formulas. You have to know them by heart. So, and the next thing to do is that the phase to note the line current is equals to the phase current for star arrangement. So for star arrangement, these are the things you need to know. The line current is equals to the phase current, and um, the line voltage is equals to root 3 of the phase voltage. So going to delta arrangement, for delta arrangement is the opposite. Line voltage is equals to the phase voltage. That is for delta arrangement. And line current is equals to the root 3 of the phase current. So these are the difference between the delta and star arrangement in three-phase circuit. So you have to know these formulas. You have to know which formula am I to use. When the question state is a delta, you know that these are the formulas you are using. And the question says is a star. These are the formulas to calculate the line current and the phase current. So, and aside that, these are formulas you also need. These are general formulas. This one, it doesn't matter whether it's a distance, whether delta or star. To calculate the power, you can use these formulas. To calculate the impedance, you can use these formulas. And we know that PF, we already know, is also equals to the power factor. PF is equals to cos phi. It's still the same. And the power in three-phase circuit. The power in three-phase circuit, we still have our apparent power, real power, and reactive power. So our apparent power here now becomes this. S here is equals to root 3 VIL. Then the reactive power, whether it's a star or delta, is given by this. And our real power is given by this. So these are the formulas that you need to really understand well to be able to perform any kind of calculations in this. Driving them is not important. Knowing how to use the formulas is the most important thing. No one will ask you to prove these formulas, but you have to know the right formula to use because you are the engineer here. So without wasting much time, let us dive in and start with some few examples. So with problem one says three identical capacitors are connected in A star and B delta to a 415 volts, 50 hertz three-phase supply. If the line current is 10 amps, determine in each case the capacitance of each of the capacitors. So they said first we should calculate for it in star, and when we finish, we should calculate for it in delta. So let us go. For the star, I will start with solution for the star. So for star arrangement, so when the capacitors are connected in star, I have I call on all my star formulas. We said for star, line current is equal to phase current, and phase line voltage is equal to phase voltage by times root 3. And they said our if the line current is 10, meaning our line current and our phase current is equal to 10 amps for star. Then we need to now calculate the phase voltage. How do we calculate the phase voltage? We say the phase voltage is equals to line voltage is equal to Vp over root times root 3. So phase voltage now equals to Vl over root 3. What was the line voltage? The line voltage is 415. So we just divide 415 by root 3. Then we have our answer as this. After getting our answer, we now need to calculate. They said when they said we should calculate the what? Determine the capacitance in each case of the capacitor. So to find the capacitance, how do we find the capacitance? We invoke our formula. Xc is equals to Vp, the phase voltage, divided by the phase current. Capacitance, yeah, we just use the formula. I is equals to this was Ohm's law. So here is now capacitance. Like let's say if it was resistance, since they said they are resistors, if it was resistance, we would have said V is equals to IR. But here is capacitance. That is why we are doing it as XC. So XC is now equals to Vp all over Ip, and we know our voltage, our phase voltage, and we know our phase current. Dividing it, we get our capacitance as 23.96 ohms. And after doing that, we now calculate the value of the capacitor. They said we should calculate the capacitance and the value of each of the capacitance. How do we calculate the value of each of the capacitor? Capacitor is equals to inductance was capacitance was is equals to 1 over 2 pi fc. So we just made c the subject, making c the subject here, we get this. So it's now equals to 1 over xc. Then dividing everything, we'll come and get our the value of our capacitance, our capacitor as 132.85 microfarad. After getting our value as 1325.85, that is for the star arrangement, we need to also calculate it for the delta arrangement. How do we do that? So we have to also invoke the delta formulas. So we know that for delta, line current is equals to the phase current times root 3, and the phase line voltage is equals to the phase voltage. Here we need to now calculate our line current. So doing that, finding our phase voltage. Now finding we are finding our phase current. Sorry, here is not voltage. Finding our phase current. Find our phase current. Our IP is this. So to find our phase current, we found out that our phase current is this. And after finding our phase current, we need to find our capacitance. And finding our capacitance, we just divide the 415 by the 5.77. After doing that, we get our capacitance. Then we now need to find the value of the capacitor. So to find the value of the capacitor, we simply divide it by our, so we just calculate the value of our capacitance. Then we are done. Okay, but our next question is the 400. volt three-phase AC motor has an output power of 22.25 kilowatts and operates at a power factor of 0.8 lagging with an efficiency of 90%. If the motor is delta connected, determine A input power and B line current, C phase current. So we know the power of efficiency. Efficiency is equals to input power over output power. So since we're calculating for input power, we'll make input power the subject. Then doing that, we get our efficiency as this. Our output power was 22 and our efficiency was 90, so that is 0.9. So we get our output power as this. After getting our output power, we need to calculate the line current. So to calculate the line current, we use the formulas, the power formulas I gave you previously. So realize that they've given us the voltage, they've given us the power factor, so we can use one of the formulas I quoted and make IL the subject. So calculating the line voltage, we can use this formula. So our IL is equals to the power, the raw power divided by root 3 VL cos phi, and cos phi is the power factor. So it now becomes 247 times 10 to the power 3 divided by divided by the root 3 times 400. 400 is the voltage, that is the power, times 0.8, that is cos phi, which is also known as the power factor. Doing that, we get our line current as 44.6. So the 44.6 is our uh, current, our line current. And after getting our line current, they said we should calculate the phase current. And for delta, what was the connections of those formulas? We said for delta connected, line current is equals to IP root the phase current root 3. So to get the phase current, we simply divide the line current by root 3. So phase current is equals to 44.6 divided by root 3. And this is how we simply calculate for our line current. Then so these things are just formula work. We didn't do anything magic here. We just used formulas to really calculate the phase current, line current, input power, and everything. Our next question says three loads, each of resistance 10 ohms, are connected in star to 440 volts three-phase supply. They said they are connected in what? Star. Determine A, the phase voltage, B, phase current, and C, the line current. So we have to, since they are connected in star, we have to invoke the star equations. We know that line current is equals to the phase current in star, and line voltage is equals to phase voltage times root 3. So the first thing they said we should determine the phase voltage. So how do we determine the phase voltage? They've given us a line voltage of 440 volts. So we can determine the phase voltage by dividing the line voltage by root 3. So we just divide the 440 volts by root 3 to get 254.03 volts. Then after doing that, we now need to also calculate for the phase currents. How do we calculate for the phase current and line current? So finding the phase current, we know that V is equals to IR, voltage times resistance, right? So we know the phase voltage, which the phase voltage was 254.03, and we know the resistance. Resistance was given to us as 100 ohms. So we simply do change of subject to calculate for IP. So calculating for the phase current will now be equals to Vp all over the phase voltage divided by the resistance, which is the 254.03 divided by the 100. Doing that, we get our phase current as 2.54 amps. After getting our phase current, realize that in star the phase current is the same as it equals to the line current. So we simply code that IL is equals to IP, which is equals to 2.54 amps. So this is how we calculate the phase current for delta and the phase current for star. So I hope these examples really help you to understand the concept of um, when motors are connected in star or when motors are connected in delta, the formulas to use and how to find the power in them. So thank you. Thank you very much for watching, and kindly remember to like, share, and subscribe for more content like this. Please and click on the notification bell. Please leave a comment. It really goes a long way to help us. And if you don't really understand, you can contact us so that we'll take you on one-on-one tutorial session so that you really understand how things are going. Take good care of yourself and be safe. Bye.